Hi, Vera Mays here with the Learning Commons. Today we're going to do a short workshop on area and volume. So I've got a couple sample problems and then I have a student here already. So we'll see what other kind of questions she brings up, which hopefully will be similar to the ones that you might have. So we're going to get started with two composite figures. So let's go. All right, so when you're shopping or you're trying to paint or do something, often you need to know the area of a wall or part of your house. So this one has a wall and it's given the dimensions of the height of 10 feet, a base of 30 feet, but they cut an opening in it so people could go in and out. And the opening measures 3 feet by 8 feet in case you have any tall people that want to come through. So what we're going to do, we're going to look at this in terms of, we've got the big wall, and then we're going to cut the doorway out of it. So the area for the big wall, the area is a rectangle. So the formula we're going to use for both of these is length times width. So the length of this one is 30 times 10. So that would give us an area of 300 feet squared minus the doorway that got cut out was 3 by 8. So that gives us 24 feet squared. And so then to find the area of the wooden part of the wall, all you'd have to do is subtract. So 300 minus 24, oops, my papers. So 276 square feet is how much wood you would have to cover this wall. I'm sorry, what's your name?
Jamie.
Jamie, is that good?
Yes.
Okay. So now we're going to do one where we added things together. So this looks like maybe you went to the circus or you're on a farm and you built something, you're going to store something. So we have two different volumes, two different shapes that we want to put together. So the first one is the nice cone that we've got, and then we're going to add the cylinder to it. So the Learning Commons has a handout, and I think the teachers have also given it to you guys, and it's in your shell, and it looks like this, and it has all the volume formulas on it. So the volume of a cone is pi r squared h. So let's put that formula down. And let's go back and get the one. So for the cylinder then is pi, the cone is 1/3 pi r squared h. So we're going to be needing a radius and a height for both of those shapes. So the radius, Jamie, can you tell me what the radius would be then?
Half the diameter.
Half of the diameter. So the diameter is 4. So the radius is 2 feet. So the first one is going to be 1/3 pi 2 squared times the height, which is the difference between the 24 and the 14, which is 10. For the cylinder, it's going to be pi. The radius is still 2. And the height on this one is 14. Now, in your homework, they ask you guys for these answers both ways, as an exact answer and as a decimal equivalent. So if they ask it for an exact answer, that means when you work it, you're not going to put 3.14, you're not going to press pi on your calculator, you're going to leave pi in your answers. So the first one, we'd have 1/3 pi, 2 squared is 4, 4 times 10 is 40. So if I multiply and simplify that, I end up with 40 pi over 3. Plus, for the second one, I'm going to have pi times 4 times 14, which is 56. So this would be an exact answer, and everything was in feet. So how many feet? What's the units? Do you know, Jamie, for volume? Because we took a foot times a foot times a foot in our formulas.
Cube.
cubed. So volume is always going to be something cubed. So this will be foot cubed for the units. And they like to mess you up on your tests and on your homework. They mix these up around. The foot may come first, foot cube may come first. So you really got to watch them to see what they're looking for. So to get the exact answer, I didn't bring my calculator. Can you put this in your calculator and see what you get? So Jamie's going to put it in the calculator for us, if there's anybody watching at home. And we're going to see the decimal equivalent.
So what exactly am I putting in?
The whole thing. Just type it in just as I have it right there. So 40 pi divided by 3 plus 56 pi. Yeah?
Sorry, my calculator's like, it keeps saying error.
So let me try it then.
Then.
Thank you. All right, so we've got 40 pi divided by 3 plus 56 times pi. And we get 217.817. Now, usually they tell you where to round these. A lot of them say to the tenths place. So that would be, the 8 would be in the tenths place, the 1 would be in the hundredths place. So let's say we were told to round this to the hundredths. That means we're rounding to the 1, so we look at the number right after it. So what does the 7 do to the 1?
Keep it at 7.
No, we're looking at the 1. Is it going to stay a 1 or is it going to go to a 2?
2.
Going to go to a 2. So 217.82 feet cubed would be our decimal approximation answer. So we have an exact answer, keeping all the pies, and then we have an approximate answer, which is much easier to go to Lowe's and say, I need about 217 cubic feet. Then you tell them, I need 40 pi over 3 plus 56 pi. They're going to look at you and kind of laugh, aren't they? Okay, so at this point, I'm going to see if Jamie has any questions. So I'm going to come over there with her, and we're going to see what questions she has. So did you have some specific ones that come to work or looking
Yeah, I
at?
understand most of what this test is going to be about.
Okay.
It's just these types of problems.
Those are the similar triangles? Okay. So let's draw this one on the board so we have a bigger one to look at. So there's our triangles. Let's label what else they gave us. So there's side of 12 over here. This is 4. This is 4. This whole thing is 18. Okay? So what I would suggest, because it looks like a little tiny triangle instead of a big triangle, right? If they're similar, that means all their proportions have a certain ratio. So I like to draw the big triangle and then the little triangle. So they gave you the 12 here, they gave you the 4 here, and the 4 here, and they gave you the 18, right? What are they looking for? Final length of CA. So they're looking for this right here. All right, so with similar triangles, we just think the ratios have to be the same, right?
Mm-hmm.
So this is proportional to this side as, let's say, this is to this side. Now, do I need to know the missing piece here? No, they didn't ask us. It doesn't have, sometimes you'll have to use it with a again, like to find the missing piece. But this one, we don't need it. So we can set up a ratio. 12 is to 4, so that compares this side to this side, as this is to this. So what does that suggest to you when you've got it set up like that? No? We're going to use a cross multiply.
Okay.
So this gets multiplied by this equals this times this. So what's 4 times 18? 17. All right, then how are you going to solve that for x?
Right, like that.
Divide by 12. Good. So x is 6. So this is 6. What are we looking for? This little piece is 6. What were the units on this? Any units? No. So it's just 6 at this point. If everything else was in feet, we'd have to put a foot with that. So they like to do this ratio thing when we do similar triangles. And you have to watch, because sometimes they'll flip one and they'll make one lane this way. So if you get them where they're oriented the same direction, it's really easy to see which one corresponds with which one. Pick another one, we still have some time.
The ones that we have like the sphere and then.
Right, like we just did, yeah. The only thing with this is you don't have the whole sphere, do you? For you, those of you at home, I'll show you the picture she has.
Could we please write the whole question on the board if possible, or read?
This is with similar triangles. And that's
No,
why we
the
do
new
picture.
question.
Oh, the next
The
one.
new question.
This is also on a handout that they're given in class. It's test 2 review measurement geometry that they have in their shell.
Okay.
All right, so this next one, this one, not an artist. So it's very similar to the one we just did, right? So when you look at this and you're breaking it apart, I still see the bottom piece, right? But instead of a whole sphere or a whole basketball type shape, you're only seeing half of it, aren't you? So when you do the volume formula for that, you're going to make sure that you have to put a half in front of it. So this will still be the volume formula that we had a while ago. This will be the pi r squared h. What's the volume formula for the basketball shape? Right? So now, for those of you at home, they gave us that this measurement was 9 meters. This measurement was 6 meters. So we need a radius, right? What's the radius for this picture? The whole distance is 6. 3. So that's one of the first things you want to do, after you figure out like which shapes you're doing. Okay. So then the radius is 3 for both of them. What's the height on the cylinder? That's the first one. Then this one, we'll go ahead and use the fractions to get everything in. And then the radius is the same radius, right? Because they're right on top of each other. And then again, did they ask you for exact or decimal? Your whole number. So this one, you would just type that straight in the calculator like that. And you get what you get. This is a nice composite type picture. They took 2 shapes and just stuck them on top of each other. You might even want to do it with these 2 separate ones, so it's not so big. I'm sorry, as long as you get the right keystrokes. Accurate is better than fast. You need a little bit of both. an hour and a half time limit. Yes. Which are 81 times 5.
Yeah.
Okay. Sometimes it's faster to do a number 5 and then multiply that by 5. You know that?
Yeah. You have that. And so like, okay,
You got it?
81 times 5.
Mm-hmm. So this covers 254. Almost there. For probably say the here's whole number. So we'll just keep 2 decimal places for now. All right. So this one, when you put it in the calculator for important, you put all your fractions probably in parentheses. So try that one. Do you have anybody watching from home?
No comments, no
Okay.
questions so far.
Any questions? Be sure if you're watching from home, let us know and then ask any questions that you have before we wrap up. I would put 1/2 and then the other third, and then multiply by the pi at the end. Doesn't matter if you put it because you're multiplying, but it's usually a little more straightforward to do all the numbers because we're more familiar with that part. See the first two fractions, all right, we'll put the parentheses, we'll put 3 raised to the third power.
It was, I was not used to, like, I got a new one, and it was more like,
Everyone's very distinct.
yeah, so I'm like, do it out with this.
Okay, you just move to the forward, by arrow.
Okay.
And then I put time 5. And this part is 56.5 and like 5. And then we would just add the 2 pieces together. So when you do that, we'll get your final answer. And then we need to think about what the units would be, because it's volume. So we know it's something to the third power. And what were the units in meters? So meters 2. Now this one says round to the nearest whole number. So you're going to get rid of the decimal part. So do it like piece, and then add your solutions together. That way it's also not so overwhelming for all the calculations.
I think we have time for just one more. We can talk about some strategies if there's something. And then we can keep working.
So this one, since it's the square, they're all the same.
Mm-hmm.
So, so for this one, since it's finely shaded,
This is, yeah, she's asking about, this is number 11 on the handout. And just real quickly, we kind of talk about the strategy here. It looks like you've got a square. And then want to cut a circle out. And so we're keeping this part, we're keeping this part, and this part, right? What did they give us? They gave us that all the way across is 12 meters. So that's the length of the square, isn't it? So what does it make the radius then for the circle? The radius is 6. So on this one, you're going to have a square that you cut away the circle part. So it's like the one where we cut the whole way out of the wall. So figure the area for this, figure the area for this, and just the half. Again, it's like 2 small problems, and that way it's not so overwhelming.
Okay, I think we'll go ahead and wrap up then with that. And if you have any questions, please come on in and let us know, or you can email us, and we'll be happy to help you. Thanks for joining us.